Hello everyone, today we're talking about robot arms. I know that they're a bit of an unusual thing to have around, but there has been a bit of a trend with YouTubers getting robot arms to move cameras around. I think for a lot of the time it's for the sake of looking cool rather than for an actual functional purpose. I think Marques Brownlee had one for a little while as well, maybe they still have one. And using them for moving cameras around is quite a good use case. They do that in films as well, which is actually something we're probably going to talk about a little bit. I have one because I think for a lot of the projects I'm going to do, it's going to be quite handy to have around, although it'll be more handy if I can find a way to control it from an external computer rather than the onboard computer over there, which is something you can do. It's a bit tricky. With KUKA arms, there's like an Ethernet interface that allows you to do that, but it has to be a package installed on the compute device. But when it comes to running robots, safety is a massive consideration. Now, believe it or not, a couple of interesting facts. Number one of the first videos I ever did on YouTube was about robot arms. This was on a completely different channel, and it's a video lost to time. And I think it was actually done with this arm specifically. And fact number two is I'm technically qualified to operate it. I mean, anyone could grab one and start using it. But alongside my dad and some other people, I attended a specific college for a specific course. It was only like a brief course for how to operate the robot arms. So it was a basic programming course, meaning you would learn about how the computers, how the pendants work, structurally how the robots work, how many axes they have. I think this is a 6-axis one. How you would write the program to control the arm, the safe modes of operation, the different speeds it can go, and just general safety. These things are designed to be used inside of cages. So if you imagine a manufacturing environment like a car factory, for a lot of the different stands, like the different points of operation along the manufacturing process, the individual actions that a robot's going to do are often repeated. So it's the same thing done over and over and over again within a confined cage, which is very specifically designed for that part of the process. So maybe like moving one component somewhere else with a gripper and then grabbing another tool to do an action, or they may even pass on to other robot arms, which themselves have different things like, arc welders or something like that as their end effector, as you would call it. But for the sake of safety, these places are most often caged off to stop people from accidentally walking into the work area. There's specific terms for it. I can't remember all the terms, but basically anywhere the robot can reach within its work parameters is somewhere that should be caged off in an environment like that, particularly if the robot is running at full speed, because some worker walking by doesn't necessarily know when the next path objective for the robot is going to be. Meaning that if you imagine an end effector at the end of this that's got a point on the end, a point which the robot could be made aware of, the potential places where that point can be are anywhere that the robot can reach, meaning that whoever's programmed the motion for the robot that it's running, it could be like somewhere over the back corner there. That may be like the next path in its programmed journey. And you won't know that if you're not qualified and if you didn't program the robot. So imagine another worker walking by behind the robot there, and then this thing flips over at full speed. It could then knock someone out. Robots can kill people. They are hefty pieces of machinery. And with this make, KUKA, one of the largest robots they do is called the Titan, which is a really chunky boy. So safety is paramount, and in an environment like this, there is really no reason to be using the robot at full speed. They can go very quickly, and people take advantage of this for different creative use cases. For example, there are lots of theme parks which use robot arms, especially KUKA arms, to fly people in very pre-designed and pre-tested motions, which are repeated again and again and again. Typically a bad idea to introduce new and unexpected positions into a path because of something known as singularity. So if you imagine the robot has a joint for every axis. So we've got one that rotates it around here. We've got this arm, so it's going to go up and down that way. Then we've got the next section, so on this joint that's going to go up and down. Then here we've got one that's going to rotate side to side. In here we've got one that's going to go up and down again. And at the end here we've got a rotational one, so the end effector can be rotated like that. So you can think about limits in two ways. You've got the limits of the actual joint itself. So this arm going down shouldn't be able to hit the ground. And if you've got a point at the end here, this should not be able to hit the robot itself. So the thing about having rotational limits is that if you imagine a smooth curve going over the space, let's say we're doing a curve that goes back and forth like this, the robot, well positioned, should be able to perform that easily. Let's say that this section was rotated upwards so that this is facing me. Technically, if I did a curve like that, all the arm would need to do here is just rotate this one back and forth. So that'd be a relatively easy motion to do. It only really requires the use of one arm. But typically, you would usually use all of these axes in conjunction. However, things become more complicated, say if this was at an awkward angle, where the joints were already stretched to their potential limits. And from an awkward, possibly essentially a stretched angle. Say if the robot arm was somewhere further over there and I wanted to achieve the curve here still, it may be able to successfully get part of the way along the curve before at least one of the axes hits a limit. So what does it do then? Because it's programmed to try and complete the curve. And this is where you may discover something which they call a singularity, which is where one of the joints hits a limit, so the robot has to do a really awkward maneuver to oftentimes spin around at different axes to reach the point again to go further. So you may see a robot do this. Imagine that my arm is a robot arm. It may go up along the curve and then suddenly spin in a weird way and then continue the curve. So this singularity is something that you need to be careful of, particularly when it comes to testing your movements. You can't just program in something that you think will work without testing it, because you may then realize that when you're actually running it in a manufacturing environment, or worse, in an entertainment environment, if you're flying someone on the arm, then it may perform a motion that's completely unexpected and could be dangerous. That's why the idea of passing untested motions to the robot arm, especially at a full speed, is something that requires a lot of caution, and you do need to take that into consideration. It's why caged environments are important with unknown variables like that, because as we said, if you're a person walking behind, if the robot has encountered a singularity at full speed, then it may perform an unexpected motion which could then knock someone out. So when we start talking about these things, you can understand why it becomes a concern when people that haven't gone through the basic training or safety qualifications get a hold of one of these and then try running it at full speed. And again, I'm thinking about other YouTubers. That's irresponsible and quite stupid. As I said, in an environment like this, where we don't have a cage, there is absolutely no reason to even try running this at full speed. Maybe more like 5 to 10%, depending. So at the moment, this would be the perfect video to get it up and running and demonstrating, but I need to tighten some bolts on the base. As you can see, it's wobbly. That's because it's been in transit. I then need to plug it into the power, plug these cables in to transmit data and power between the robot and the computer over there, and then also get the pendant plugged in. So I may do that off screen, off video. Sorry if that's disappointing, but we can take the opportunity to talk a bit more. I can show you the pendant, so how people actually operate it. So this is the pendant for this robot, and this is an old version. The newer versions of the robots have more touchscreen elements. And as you can see, this is just a lot of buttons. And it's very clunky, it's very chunky, but despite that, it is quite well designed. Now, if the robot isn't running in an automated mode where it's just performing the same actions again and again on its own, like in a car manufacturing environment, then it requires someone to be at the pendant, actively watching and actively holding it in a certain way to let the robot run. This is for safety reasons again. Typically on this device, there is this key here. You can pull it out and it's an actual key. So again, for safe operation, only people that are qualified to use it should use it. You can put the key in and you have access to different modes. So what I'm seeing here there are different test modes that are represented by a T on the pendant. So you can choose different speeds. Obviously for safety, I will leave that on the slowest test speed so that when I come to booting this up and when I'm operating it, it's going to go as slow as it possibly can. Now, when you're actually running a program on this, look at the back of the pendant. You see we've got all these little weird buttons and bars. If it's not in a closed cage environment and you're running it manually, you have to hold the pendant in a certain way to provide a safe signal to the computer to say that the program can run. So for example, I'm going to hold it over the top here and you see this white bar that I can push in. Every single one of these operation buttons, so we've got one here, we've got the bar on the side here, and then we've got a white button here. They all work in the same way. You have to hold them down halfway and keep them held halfway to allow the program to run. So to keep the robot moving, this has to be held at all times in a halfway position. Why halfway? It's actually quite a genius design, and it's not always super obvious. The reason is because when you're working, again, in environments where something can catastrophically go wrong at any second, the human body is going to have two shock reactions. You're either going to let go of the pendant or you're either going to clamp hard onto it in shock, should we say. Both of those actions is going to stop the robot from moving immediately. That's why you have to put in mental effort to hold it halfway. And it very often happens where you're testing a program and all of a sudden the robot stops because you didn't realize that you weren't paying attention to your grip strength and you accidentally let go slightly too much. And then it stopped. But that's better because it's better to be safe than sorry. So they're very well designed in this way. Now, the reason why one of them is a button, like a round button rather than a bar, is because if I get my hand under, you're going to be holding it like this. So you can see that the thumb rests over the green button, which actually tells the program to go, to run. And one of your fingers rests over the halfway button. So you halfway to prime it, and then you can press to run it with the green. And again, doing that is just going to stop the robot, or clamping in is also going to stop the robot. You may also look at this and think, what is that giant white thing there? That's the mouse. So this is another way to operate the robot. It's a way that you can creatively move multiple axes at once, and it takes a bit of skill to get used to. Again, if you're holding it down into the halfway position and you're in a mode where you can move the robot, by moving this mouse, by tilting it slightly in any direction or twisting it or pushing it in or pulling it out, is going to move one of the axes respectively. So with this in mind, if you develop an intuition for how to move this, you can, instead of looking at the individual arms or moving the arms individually, which you would do by using the different axes buttons here, you can instead just look at the end effector on the robot, move the mouse, and then you have an instinct for which direction it should move. So if you learn how to use this, it's a much more fluid way of moving the point around. I should also say the much more obvious way to stop the robot if something goes wrong is with the big red E-stop button, the emergency stop. So again, some people would rather just slam that down if they need to. The other buttons on the screen are again for, first of all, programming things in. There you go, you got your letters and numbers there. We've got buttons to play and do the motions in reverse. We've got another stop button there, stop buttons everywhere, ways to make new files. And again, these buttons down here individually either add positive or negative movement or translation to the different arm axes. When it comes to actually making the programs, the motion paths, you can move the robot to the necessary position using these different control methods and then enter that in as a position. And the actual code files are stored as two files. There's a .dat and a .src file, if I remember rightly, because I wrote a program once in the past to convert animation data in Maya into files which would be then understood by the robots. I did this for a company that actually flies actors and props and set pieces on robot arms, because that company is co-owned by my father, which then completes the circuit of the question for how do I have access to one of these. So the company in question is called RoboMoko. They're not the only company that's flying people and props on robot arms, but I will tell you they're definitely the safest from what I've seen, because they've always put a massive emphasis on safety. I believe there's also another system that runs in parallel called Safe Robot that double checks what's happening on the system. And separately from the actual KUKA basic programming course I then did a safe operation training course with RoboMoko, which is all about safe operation and testing the robots for on-set environments. And all of that's done with authorization from KUKA. Again, the same can't be said for people that just obtain a proper robot arm from a secondhand market. For example, they see a company like RoboMoko or random other people online flying people. They think, hey, that's fun. Let's do that. It'll be cool. We'll be like Tony Stark or something with a robot arm, without actually being educated about the dangers of using robot arms, which can very easily kill someone at high speed. So maybe we'll take another look at this in a later video. Again, I'm not going to rush to get it set up because, like I said, I have some understanding of the system. I'm going to do it properly, make sure it's all okay, rather than just rushing it for the sake of showing you it on this video. But hopefully you learned something. It's nice to give a little bit of info from something else I'm interested in. And it's a little bit full circle as well. Like I said, years ago, one of my first YouTube videos was actually sitting down when I was like 16 or something in our old garage and talking about how to use the robots. So yeah, thanks for listening. And if you made it to the end of this video, please put some kind of emoji in the comments. I think there's a robot arm type emoji, like a cybernetic looking thing. That will show me if you made it this far. So thanks for watching, everyone. Stay safe, and I will see you next time.